Hello all, in today's lecture we'll be studying about don't care conditions. What do you mean by don't care condition? Say in normal digital systems, certain combination of inputs, they never occur during the normal operation. And these combinations, they guaranteed that they don't occur. These combinations are called as don't care conditions. Say for example, let's take the example of a traffic light. How many lights are there? We have three lights like red, amber and green. Fine. Let me take these three lights as three variables. Fine. So for a three variable, how many combinations we can have? It is 2 power 3 which is equal to 8. Right. Now what are the combinations? It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Now when you consider this case, red light can be off, amber can be off and green can be off. Meaning all the three lights can be off at a time. So this condition, it is valid. Not necessary the light has to be on all the time. Fine. Now a green light, amber, when green light is on, amber and red will be off. Right. So this condition is again valid. When amber is on, red light and green light will be in off mode. So this condition is again valid. When red light is on, amber and green will be in off mode, right? So this condition is again valid. Now tell me this, can amber light and green light go on at the same time? No, that combination is not possible, right? Check with this. Can red light and green light go on together at the same time? No, this is again not possible. Check for this. Can red light and amber light turn on at the same time? This is again not possible. Can red light, amber and green, can all the three lights turn on at the same time? No, this condition is again not possible. These conditions are called as, that is, wherever I put a cross mark, these conditions are called as don't care conditions. What does it mean? In certain digital system, certain combination of inputs, they don't occur in the normal operation. And it is guaranteed that these combinations can never occur. Fine? These are combinations. These are called as don't care conditions. Understood? Now, let's solve some few problems based on which you'll understand how we are using this don't care condition in K-map for getting a simplified Boolean expression. Fine. We have two problems. One is with using SOP, another is using POS. Now, this D, don't care conditions can be represented using the letter D or by using phi. These are two symbols or two variables that is used for referring to don't care conditions. Got it? Let's solve the problem. With that, you will be understanding better how to use the don't care condition in K-map for getting a simplified Boolean expression. Let's take the first problem. How many variables are here? We have got 4 variables. So which variable mapping you will be using? 4 variable mapping, right? Okay. On the left hand side, I have 2 variables. So for 2 variable, how many combination is possible? 4 combinations. What are the combinations? It is 0, 0, 0, 1, 1, 0 and 1, 1. Why did I write 1, 1 here and 1, 0 here? We have explained it in the previous lecture itself. If you have not seen that lecture, please go back and refer to it. I'll give the link of that lecture in the description as well for easy navigation. Fine. Here again, we have two variables. So how many combination is possible? We have 4 combinations. Fine. The next step is to write the decimal number inside the boxes. You write the decimal number now. Got it? Okay. What is the next step? Positioning these values inside the K-map. This is an SOP. So for SOP, how will you position the numbers? By using 1. Good. Now, whatever number is there given in the question, these are the decimal number and these number corresponds to these numbers. Fine. Whatever number is there given for you in the question, you have to represent those number inside the boxes in their corresponding place with 1. Fine. 1. And your next number, it is 3. So in the place of 3, put a 1. And next it is 7. In the place of 7, mention a 1. 11. Where is 11? 11 is here. In the place of 11, mention a 1. And the next number, it is 15. In the place of 15, mention a 1. Understood? Now we have positioned these numbers inside the K-map. We should also mark the don't care conditions as well inside the K-map. Fine. But to differentiate that these are don't care conditions, we will be marking all the don't care conditions by representing them with a X. Clear? Irrespective of whether it is in SOP or whether it is in POS. All the don't care conditions will be representing them by X. Clear? Okay. Now what are the numbers? It is 0. In the place of 0, put an X. And next it is 2. In the place of 2, put an X. The next number, it is 5. So in the place of 5, put an X. These don't care conditions, listen carefully, these don't care conditions are mainly used for grouping, helping the actual minterms in getting into a group. Fine. As such, you cannot group these numbers alone separately. They are not standalone. They cannot stand alone. They are mainly used for helping the minterms to make a group. Understood? Fine. Now, can you do the grouping? Do we have a 16 here? Are we having 1 in all the boxes? No. So 16 grouping is not possible. The next, what you have to see? You have to see for an octave. Octave is 8. Can we do a 8 number grouping? No. That is again not possible here. We don't have any 1 in sequence. The next grouping, it is 4, which is quad. Yes, we can make a quad here. This is one quad, right? Here again, you can make it another quad. These don't care conditions are used to make the actual minterms form a group. These actually help the actual minterms to form a group. Which are the actual minterms? These are my actual minterms. Understood? Now there is one X left here. What did I say? Don't care conditions, they cannot stand alone, but they will help the actual numbers in grouping. Now this X and this X has helped these two numbers in making them in forming a group, right? There is no necessity of this X. The reason being, already all the minterms are grouped. There is no minterm that is left empty now. There is no minterm that is left without grouping. We have grouped all the minterms. When we have done with grouping all the minterms, then there is no necessity of worrying about X. Our main focus should be to group the minterms in such a way that in case if we are not able to group the minterms, we can make use of the don't care conditions in making it a group. Understood? Now, can you give me the equation f of a, b, c, d? It is equal to, let me take this bubble now. So for this bubble, which is common on the vertical side, while you're checking, you have to check for all the terms. Let me take the first term here. The first term, here it is a bar, b bar. This is a bar, b. All the first term corresponds to the letter A and all the second term corresponds to the letter B. In SOP, 0 is represented with complement, that is a bar, and 1 is represented with the actual variable. If it is A, then in case for SOP, if it is 1, then you represent the actual variable. Whatever might be the variable, A, B, C, D, whatever might be the variable. By chance, if it is 0, then you represent that with a complement. Understood how I have written here? Here, all the first row corresponds to A and all the second row corresponds to B. Right? Now, since it is 0, I've mentioned that as A bar. Here, second element is again 0, so that I've mentioned it as B bar. Here, the first element corresponds to A, but it is 0. So I put it as a complement. The second element corresponds to B. And since it is 1, I can represent that as an actual variable, that is B. Understood? In a similar way, can you say for this? It is AB and this is AB bar. Got it? Here again, let's write. This is C bar, D bar. All the horizontal terms refer to the variable C and D. Fine. The first variable corresponds to the letter C and the second variable corresponds to the letter D. Fine. C, D, C, D, C, D bar. Clear? Now, check for this bubble, which is common on the vertical. Here it is A bar. Let me take the first column again, column alone. When you take for this particular bubble, when you are checking it on the vertical side, let's take the first column again. For that, it is here it is A bar. It is matching with the second element, but here it is differing. Here it is A. A and A bar are not the same. Fine. Common element meaning all the elements can have A, or either it can have A or it can have A bar. Fine. Two elements having A and two elements having A bar is not it cannot be included as a common term. Common term meaning for all the elements inside this bubble, there should be some common term. Only then we will be able to take it. Here, when you see the first two terms are A bar, the second two terms are A. So it is not common here. It is differing. So the first element we will ignore. Let's check on the second element now. Here it is B bar, here it is B. Initially itself it's a difference, so we will ignore it. Now go for the vertical. Horizontal. Here on the horizontal, C and D is common to this element, again to this element, and to the last element as well inside this bubble. So for this bubble, common term it is C, D, right? Now take for this bubble, which is common here. For all the elements inside this bubble, A bar, B bar is common, right? So I'll write A bar, B bar. You have to check horizontally as well as vertically to complete a min term. Min term meaning for every bubble, you'll be having one min term. And these min terms are the product terms. Got it? Now, for this bubble, check on the horizontal part. Check the first element now. Here it is C bar. Here again it is C bar, so it is matching. But here it is C, so it is differing. So we can now take the first element. Now, let's check on the second element now. Here it is D bar, here it is D. Initially itself it's differing, so we cannot take any of the elements here. Clear? So my final equation is only this. Understood how to write the equation? Using a don't care condition? Now, let's move on with the second problem. Here again, how many variables are there? We have 4 variables. So, which variable map you will be taking? You will be taking a 4 variable map. Give me the term, possible combinations as well. It is 0, 0, 1, 0, 1, 1, 1, 0. Here again it is 0, 0, 0, 1, 1, 1 and 1, 0. Clear? Now, since it is, check for the symbol here. It is pi. Pi meaning it is POS. So how you will be representing the terms inside the K map? You will be representing them using a 0. Fine. Now, fill the decimal part also. It is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Fine. Now, these are the max terms. Max term meaning sum terms. So, accordingly, give the expression for this also. In POS, we already know 0 is represented with actual variable and 1 is represented with complement. POS is just the exact complement of SOP. Clear? In SOP, 1 we referred with actual variable, whereas in POS, 1 will be represented with a complement. Clear? And in SOP, all the terms are represented as a product term, whereas in case of POS, we are going to represent them as a sum term. How you will be representing them as a sum term? This is A plus B. First term refers to letter A, second term refers to the letter B. Fine. Now, for this, it is A plus B bar. This is A bar plus B bar. Why am I writing B bar for 1 and A bar for 1? Because 1 is represented with a complement. Clear? 0 is represented with the actual variable. So wherever 0 is there, that particular term I'll be representing it as such. But wherever 1 is there, I'll be representing that with a complement. Clear? Now, for this it is a bar plus b. Got it? In a similar way, can we write the horizontal part as well? It is c plus d, c plus d bar, c bar plus d bar, c bar plus d. Clear? Now, position these numbers inside the K-map. How do you position? Since it is pi, you'll be positioning them using a letter 0. Fine. Now, wherever this number is there, corresponding place, put a 0. What is the second number? It is 5. Third number, it is 6. Fourth number, it is 7. And then comes to 8 and then 12. Fine. These are the actual max terms that are given for me in the question. Now, you have to include the don't care conditions as well. I told you beginning itself, how do you represent the don't care condition inside the K-map? You represent them using a letter X to differentiate and to make the user understand that these terms are the don't care condition terms. Fine. Now, wherever this particular number is there, put a X mark there. So 1, 2, 3, 2, 3, and then 9. The next term it is 11, and then it is 14. Clear? This is how I'll be positioning the max terms along with the don't care conditions inside the K-map. My next step is to do the mapping. File mapping, check whether 16 is possible. Here 16 is not possible. 16 meaning 16, if you have 0 or X in all the boxes, when the entire box is full, either with 0 or with X, then that means you are going to group that into a single group, that is 16. Here we have vacant space, so 16 is not possible. What is the next possible combination? Go for checking with the octave. Octave, it is 8 number group. Here you can use the don't care conditions for grouping. Got it? So I have got an octave here. Is there any other octave possible? No. Right? So what is the next priority I have to check? I have to check for quad. Quad meaning it is 4 numbers. So this combination I can take. Is there any other quad possible? No. Also check whether I have mapped all my max terms. My priority is to map all the max term. If I am done with mapping all the max term, then there is no necessity of the don't care conditions that is left. Here, when you check, I have all the max terms I have mapped. There is no max term empty left over. So my mapping is done. Now I have to write my equation. F of a, b, c, d is equal to, let me take the octave first. For the octave, on the vertical, which is common? A is common. Right? My second element here, it is b and b bar. So it is different. Whereas the first element, it is a and a. A is matching. So I'll be taking a plus. Check on the vertical, horizontal as well. Is there any element common here? First element is C, again C. I'm checking on the first element now. Here it is C, C, and here it is changing to C bar. So first element I cannot take since it is different. Go for checking with the second element. Here it is D, and here it is D bar. Initially itself it is changing, so there is no second element as well. So there is only one element for this particular bubble. Now, let me take this bubble now. For this particular bubble, is there anything common here on the vertical? Check for the first element. It is A bar. It is differing. I cannot take A now. Now go for B. Here B, it is B bar. Initially itself is differing, so I cannot take B also. Now, check on the horizontal. Which is common? C plus D is common. So C plus D. This is my final answer. Understood? Why am I not grouping this X, X and X? I told you in the beginning itself, don't care conditions, they don't stand alone. They are, as such, they don't have any meaning. But they help the actual min terms or the max term for grouping. I have grouped all my max terms here. So I don't want to look into these don't care conditions now. This is how you'll be using don't care condition in K-map for getting a simplified Boolean expression. I hope you're clear with the concept. It is B. In the next topic, you'll be studying about tabulation method or the Quine-McCluskey method. Why do you go for Quine-McCluskey method? In K-map, we have a disadvantage like, say for example, your Boolean function that is being given to you, if it has got more than 6 or 7 variable, then in that case, we can solve using a K-map, but it is going to become very tedious. And that is the reason we'll be going for another method called tabulation method, or it is also called as Quine-McCluskey method, which we'll be studying it in the next lecture. I hope you're clear with today's lecture. If you find this video useful and informative, please do like, share and subscribe to my channel. Thank you.